So as I was saying, the way I usually do this is I will just answer questions about particular problems on exams. I don't usually, I mean, if you have a topic that you want to address, we can address the topic, but I usually try to keep these help sessions just centered around the exams, especially as we're preparing for a quiz, because remember, the quiz will come directly from these exams. What did I say? Was it 17 through 21? 17, 18, 19, 20, yeah. So the last 5 years, 2017 up to last year. So are there any particular questions that you want to work through? In general, it's sort of the first 10 to 12 questions on each exam. You can see where I shift. I hope you can see where we shift from the topics that we've been covering to kinematics, which is the study of velocity and acceleration, motion. You'll see graphs and the like. Any particular questions?
How do you get to the thing with all the different years?
Oh, yeah. So that's a good question. Yeah, some students, it takes them a while to just this website is on Moodle. It's linked on Moodle, and if you go down, you see exam videos. It's like the 8th or 9th link, and click on that, and then it has all the exams since 2008. So like I said, for this, we're just picking up with 2017 and going up, but it still might be useful to practice the other exams. Every question is a little bit different for the most part. Occasionally I'll reuse a question, but almost every question is different. So that way, if you practice one exam and you think you've got it, then you can go to another exam and you're practicing the same skills and the same information and content, but you're doing it in a different way, which is great because it's going to be the same for the exam. That they'll all be different questions, but they'll still be covering the same material. Okay? For now, don't worry about the free response at all. I'm going to address that next week when we get into that, and I'll tell you what to expect for the exam in a week and a half, a week from Wednesday. Okay? Any other particular questions? If there are no questions, I'll just scroll through some, and we'll look at the different classes of questions that you'll see on the quiz come Monday. Is that what you want to do?
Yeah.
Okay. Well, if you see something on one of these exams that I pull up, say, hey, can we look at that? And by the way, also in the back of your workbook, I think I have the fall 21 exams. Is that right? Yeah, so I'll start with the fall 21, so you can write in that. It's a little easier to take notes. But then we can look at some of those other exams as we go on. Okay, so you'll have one or two estimation problems. Usually on every exam, I have 2 of these. And honestly, like your quiz is going to look a lot like the first and second page of each exam 1. I'll have 2 of these, 2-dimensional analysis, a unit conversion. I'll have all that. You might have just 1, say, estimation. You might have 2, I don't know. But here I had 2. And I want to know what is the area of an actual wristwatch dial. So, you have a watch. Everybody have a watch? Most of you have watches. Oh, do most of you have watches? Most of you do not have watches. Is that right? How many of you have a wristwatch? Hey, tell me your name.
Austin.
Austin. What's Austin? Huh?
Austin.
Right. Gotcha. All right. So if you look at your wristwatch or look at your wrist or whatever, and I want to imagine how big that is. Now, let's imagine what a centimeter square is. That's a centimeter square, right? Well, actually, that's kind of big for a centimeter square, but this is my centimeter, roughly. About like that. That's a square centimeter. But a wristwatch dial is actually about that big. So that's kind of a big wristwatch.
I was about to say, I'd argue that.
If you have one of those huge Garmins that they used to make, you remember those big Garmins that they used to make when they first came out back in the early 2000s? No. Okay. Say this is your wristwatch dial. Well, how many times does that fit into that wristwatch dial? 3? Oh no. I mean, it can fit maybe 3 across, but it's not gonna be, so once I have sort of that general idea about how big it is, then I want to ask, let's see, so here's my wristwatch dial. How many times does this fit into there? Well, it's not a tenth, right? I mean, the wristwatch is bigger, so it's definitely not that. It's also not 100, so it's either 1 or 10. What do you think it is? It's going to be 10, right? So you want to do that sort of gymnastics where you think about, okay, what is this unit? What is the length or the area of the unit? And then ask yourself, how many times does that fit into it? In order to do that, you need to know what is a meter. You need to know what is a centimeter, the width of your pinky. You need to know, what is a second. And you need to know what is a kilogram, a little more than 2 pounds. Also, what is the length of a typical pencil? This is a pen, but if I were to imagine this, is it 0.00? Ooh, so here I give it in meters instead of centimeters. Can you imagine how many centimeters this is? Is it 1, 10, 100, 1,000? 10. So it's 10 centimeters, and 10 centimeters. If I convert this into meters, is how many meters? 0.1. There are 100 centimeters in a meter, so 10 centimeters is a tenth of a meter. I can do that unit conversion, by the way. In 1 meter, there are 100 centimeters, so that's going to be 0.1 meters. But you see that the other options just don't make any sense, because the 1 meter pen would be a pen like this long. And even on those longest pens that you get at like the carnival, they're only about a foot long, right? The big pencils. And then the next answer down is a tenth of a centimeter. That would be a tiny little pencil, or a tenth would be just 1 centimeter long, and that would be a pen about that long. Okay, so those answers don't make any sense at all when we consider the physical object. So those are the estimation problems. Look back at some of those others. Look at all of them, because you'll see all the different scenarios, and they're all a little bit different. Like I think I had one question is, what is the typical walking speed of a person? And I said, speed is distance over time. What is the typical walking speed of a person?
That completely depends on how long your legs are.
Well, not that much, really. I mean, is it about 1 meter per second? Is it 0.1 meters per second? That would be like this. Nobody walks like this. Some people might walk like that, but not most people. And it's not 10 meters per second, right? That would be, I can't even walk 10 meters per second. But it's going to be about 1 meter per second. Okay? Don't be too overwhelmed by the estimation. Often students are kind of overwhelmed, but it's not meant to be difficult. It's just meant to see, do you have some knowledge of what these measurements are, these actual metric things. The other thing that people have trouble with are these dimensional analysis. Do you have trouble with these? Scare you just a little bit? Yeah. It's because of the algebra. That really, the algebra can be a little difficult, and also dealing with the fractions. Let's look at these. This is a good one, because these are a little bit difficult. First of all, when you look at these equations, I'm going to zoom in just a little bit. You want to see if you can simplify them in any way. So for example, if there's any common term that I can cancel out from all of them, it doesn't look like there are any common terms that I can cancel out. Now, if there was an x in that third term up here, then I could cancel it out from all three. But remember, in an equation, if I do something to one side, I have to do it to the other side in order to still make it equal. So in order to do this, I can just forget about these constants right here, that coefficient, and then I put in the units for each variable. X, gosh, what are the units of x? Meters, right. And then t is seconds, and then x squared is meters squared. And when I have v in the denominator, it looks like this, v meters over seconds. Emmy?
Instead of doing like meters over seconds, whatever, could you do like, let's say, meters times seconds to the negative first?
Yeah, so I think actually a better way to write this, which is what you're getting at a little bit, I think. I think a better way to write this is to write this as meters squared over 1 and seconds over meters. See, because when I have 1 over velocity, like I have right here, that's 1 over meters per second, which is equivalent to seconds over meters. Anytime I bring a fraction up into the numerator, it flips the fraction. So when I do this, I can see that this meter cancels out with one of those meters. And so far, this first equation is dimensionally correct. Y'all see that? Because I have the same units in the first term and in that other term. Y'all with me on that? You see? What about that third term? Is it dimensionally correct? The acceleration and time cubed? You think so?
Yeah, I think it works out.
Let's see. So I have meters per second squared. And then I have time cubed. That's seconds cubed. So I get these seconds squared cancels out with two of those. And you're right, Chloe. All three of those terms have the same unit of meters seconds. Okay? Can y'all look at these other two and tell me if they're dimensionally correct? The second one is, right? Remember the naught on that V is just, it's describing that it's an initial condition. Actually, this second equation is one that we'll use in chapter 2. So I have meters per second equals meters per second, and then meters per second squared times seconds. That cancels and leaves me just meters per second. So you're right. What about the third one?
It's correct,
It's
too.
correct, because it's meters equals meters, which, and then the A t squared equals out to meters.
That's right. So I'm putting in the units for every variable, and they all cancel out to give me meters all the way through. So you want, if you have these equations where you're adding things, it's very important that every term have the same units. Usually if they're not correct, I will make it so that they all have different units. So just go through the entire thing and make sure that they're all different, okay? But if any one is different, then it's not correct. So the answer here would be E. Don't think that I don't use all of these or none of these. It's not that I use those options a lot, but there are valid options that I will sometimes use. The other type of dimensional analysis, and you're going to have both of these, by the way, on your quiz. You'll have one like the one we just did, and you'll have one like this, where I ask you what are the units of one of the variables. This one's actually not that difficult to solve. Well, I want to get R all by itself. What do I do to get R all by itself? Okay, yeah, so I have R times T. So if I want to get that R all by itself, I would divide both sides by T. So if I divide this by T, and I'm going to think of it as multiplying by 1 over T over here. Those are the same. And then that gets rid of that T there. So I have R is equal to A over TV. Now I put in the units for A. I try to simplify this as much as I can, but here there's nothing for me to cancel out. Like if I had V squared over V, then I could cancel out some of the V's. But here I don't have anything like that. I'm going to write my A as 1 over meters per second squared. And you see those variables that I have in the denominator? I'm going to write them separately as fractions. 1 over seconds, and then watch this, seconds over meters. You'll see what I did there? 1 over V is 1 over meters per second. That's equal to seconds over meters. It'll save you some grief if you do that, okay? These seconds cancel, those meters cancel, and I'm left with a 1 over second squared. You'll have both of those. I mean, not those particular questions. You could have those particular questions, but you'll have both of those for the exam. Sig figs, you'll need to know the standards for all of the metric measurements. Let's just sort of zoom through here. We can come back to any or all of these. I'm just sort of going through. You're going to have trig. Like I told y'all in class, you will have 2 questions with a right triangle. I'm just going to give you a triangle. I'll say, what is this side? What is this angle? So you need to go through, make sure that you practice that, that you can put it into your calculator properly and get the answer correctly. Checking your mode, checking the way you do your parentheses, all that. You're going to have unit conversions. So here's a unit conversion. Let's do this one. This is a unit conversion where first I have to convert my inches to centimeters and then calculate the volume of that. So 2 steps in this problem. I have 4 inches. And I want to convert that into centimeters because ultimately I want my volume in cubic centimeters. So 4 inches, let's see, what is my first conversion factor? I have to convert it to feet first, so 1 foot is 12 inches. And then I convert those inches,
To meters.
or the feet to meters, yes. So the feet is 3.28 and 1 meter. Notice how I do these conversion factors, that the inches cancel there, the feet cancel there. Oh, but I'm not done because I also need to convert it into centimeters. How many centimeters in a meter?
100.
There are 100 centimeters. So I have 1 meter down here and 100 centimeters up here. Again, my units cancel there and there. So now I've converted that 4 inches into 100 centimeters. So that, or excuse me, into whatever that is. Somebody's about to tell me, I'm sure. 10.16. So I'll just have 10 centimeters. And then if I want to calculate the volume, I could say the volume is 4/3 times pi times 10 cubed. That's going to be about 4,000. Okay? You'll follow me on that? You'll have questions like that where you have to do conversions. Another way that you could have done this is that you could have converted the inches, or excuse me, just kept it in inches and calculated the volume and then converted that into the cubic inches to cubic centimeters. But this is probably the easier way to do this. How many millimeters are in a meter? How many millimeters are there in a meter?
1,000.
There are 1,000, right. Are there any specific questions in these that we've seen, or do you want to go look at some of the other exams? Other exams? Is that okay? How y'all feeling about this quiz? Easy? Is it going to be an easy quiz? I hope that it's an easy quiz. That's my intent. But I know that if your math preparation hasn't been so good, then this quiz is probably a little bit scary to you. Is it a little bit scary? Yeah? What's your question? Yeah, you want to do one of those? Yeah, so absolutely. Every type of question is on the quiz. So your significant figures question will look something like this. It might be, tell me what the answer is to this operation, or tell me how many sig figs it'll have. On one like this, it's probably easier to just go ahead and calculate the answer. So I'm going to start with what's in parentheses, following the order of operations. 2.4 minus 1 is 1.4, but I keep the lowest number of sig fig, or excuse me, not the lowest number of sig figs, the lowest number of what? Decimal places. When I add and subtract, keep the lowest number of decimal places. So that would be 3.25 plus 45 divided by 1. That would be 3.25 plus, well, 45 divided by 1, what's that equal to? 50, right. I changed that to 50 because I'm keeping just one sig fig. When I multiply or divide, I keep the lowest number of significant figures, and now I'm going to keep the lowest number of decimal places, so the answer would just be 53, and notice that has 2 sig figs. That's probably the easier way to do that. If you have a simpler thing where it's just multiplication and division, you can just pick the number that has the lowest number of sig figs, and then that's your answer. That number of sig figs is your answer. Oh, what's the standard of the second? I forget.
Yeah, that one.
Which one is it?
It's easier.
Are you sure? I thought it was the speed of light.
No, that's something else.
What is the speed of light? That's for the meter. Oh, but what's the Planck constant? Kilogram, right? So be careful because you'll probably see all of these. This is for the second, this is for the kilogram, and then this is for the meter. Sometimes it can be a little bit confusing if you're not familiar with them, that you might get your time mixed up with your meter, mixed up with your kilogram. But just, I said, put them on a note card, do whatever you need to do, and to remember those standards. Yeah. Tell me your name again. Brandon. Brandon? Braden. All right, Braden. Shoot.
It's asking for like the hypotenuse, but
Yeah.
B squared plus B squared.
Mhm.
Yeah, that one.
Yeah, let's try it. Is the answer not there?
It will, square root of 3 squared is 3, and then plus 1 is 4.
Square root of 4.
Yeah, square root of 3 plus 1 squared. And then I do the square root of that. So that's 3 plus 1 root. That's root 4, which is 2. So E is the right answer. I love to make exams where you don't need calculators, by the way. So try not, like I said, try not to use them. And then remember how to do the angle here? This is a special triangle. How to do the angle. I have,
You need a calculator for this, though, right?
yeah, you probably want to use a calculator, yeah. Although, no, I don't think so. Like, you could probably look at this and tell me what the answer is.
Not true. Probably.
No, you don't need trig. Just look at the picture. 60, right? Because you see, this angle is definitely bigger than 45 degrees. Because this side is bigger than this side. So that gets rid of this, and this, and it's definitely not 90 degrees. So the answer is 60. I love for students to do that, to be able to find the answer because they've gotten rid of all the ridiculous answers. All right, but if that's not the case, if there are a couple of options there that you need to pick from, then you need to determine which trig function you want to use. Gosh, which would that be? Tan, right, because I know the opposite and the adjacent. What's the mnemonic? It's like some,
Soft.
I know, but no, there's like some old hippie told another, or some whole,
I don't even remember.
Yeah.
We have to come up with our own ones for a project.
no, there's some hippie thing about, I mean, no offense to hippies. Are there any
It's
hippies in the
something
class?
about hippie.
Yes, something about an old hippie. SOHCAHTOA probably works better. So tangent is opposite over adjacent. Tan theta equals the opposite, which would be root 3 over 1. And remember, to solve this equation, this is what I'm doing. I'm taking the inverse tan of this side and the inverse tan of that side. So that gets, goodness, Chloe,
Sorry.
that gets rid of that tangent and gives me a theta of root 3. And that's going to be 60 degrees if you try that. That is a special triangle when you do your MCAT, the pre-med students, when you do your MCAT studies, which you'll need to devote 3 to 4 months at least of devoted study for the MCAT. They'll have in the book, some special triangles that you'll just need to memorize, and this is one of them. Yeah. Mm-hmm. Yeah, the hypotenuse too. Yeah. It's the 30, 60, 90 triangle. Right. So this is 30 degrees, this is 60 degrees, and this is 90 degrees. We'll use, like I said, the 3, 4, 5 triangle a lot too. The 3, 4, 5 triangle, this angle is 37 and this angle is 53. If you just go ahead and memorize those triangles, you save yourself a little heartache. But don't forget, you can always determine those angles with your calculator.
So when you can do the tan with the negative one versus the regular tan.
Oh, so if you want to determine the angle theta, the way that you isolate theta from tan theta is to take the arctan, or the inverse tangent. And that's this tan to the minus 1 right here, and it cancels out effectively that tangent, and it just leaves you with the theta. Remember, you have to do same side, you have to do the same thing to both sides of the equation. So what you're doing there is the inverse tangent of both sides. And on the theta side, it just gets rid of the tangent altogether. That's why they call it an inverse tan, because it's like 1 over tan. But then on the other side, you're taking the tangent of a number. Okay? All right, so we're going to stop. Whenever you come to something like this, where it's talking about something traveling at a certain speed or acceleration, then you stop. Although that's going to be your material to study for next week as we get ready for the exam, which is coming up soon. It's exciting. Oh, what is the area of a typical space bar?
Probably guess C.
C, would you guess because it's C or because you think it's 10 centimeters squared?
Because it means 10 centimeters.
Right. I mean, the tip of my pinky is about a square centimeter, 1 centimeter by 1 centimeter, roughly. See how that's about 1 square centimeter? And so my space bar has about 10 of those across. There's definitely not 1 square centimeter. That would be a space bar that big. And it's definitely not 100 square centimeters because that would be a space bar about that big. That would be a big old space bar, wouldn't it? All right. You want to do some more dimensional analysis?
Sure.
Like, let's do this one. This one's a little bit different because I can make it a little simpler. Y'all don't have this in your workbook, I'm sorry, but you can take notes or whatever. By the way, y'all don't have to send me your notes. Please do not send me your notes. Okay? Like I already have your attendance noted here, so you don't need to send me your notes. It's only people that aren't attending. So here, V, I can get rid of V on one side, or actually I can multiply both sides by V, and that makes this V cubed. And then I want to divide both sides by X, and so I get 1 over X here. So I get R is equal to AV cubed over XT. Now I'm going to put in units. I like to separate these all into fractions. So I have meters per second squared. That's the acceleration. What is V?
Meters per second.
That's the velocity. That's meters per second. But it's cubed. Don't forget to cube both terms. Okay, they're both cubed. And then I have 1 over meters. That's the 1 over X. And 1 over seconds. I can cancel out some things here. Meters cancel. And so I get meters cubed over what? S to the 6. So A is the right answer there. Yeah, Eli. Why did the V come cubed? Yeah, I did that quickly, didn't I? Let me go back here. So I'm going to solve this for R. In order to solve it for R, I'm going to multiply both sides by V over X. The reason I did that is because it cancels out the V there and cancels out the X there and there. Right, I want to isolate that R all by itself. Then I have this V and this V squared, and so that becomes V cubed. Yeah, Bryson. No, you need to know that. Yeah, so I give you this question just as it is. So he asked, am I going to give you the conversions? X is M, V is meters per second, A is meters per second squared. No, I want you to know that. I think that you do know that, in fact. But I know, you just want to know if it's going to be there. Right, y'all know that? X is M, V is meters per second, A is what? Gosh, what is A?
Meters per second squared.
Meters per second squared. Those are really the only, huh? Those are really the only ones that you need, I think. Yeah. Yeah, let's go down to 2017. I'm expecting your exam to be chapters 1 and 2. So your exam will look a lot like other exams. Is this, tell me your name again? Oh, right, Olivia. Bio. Is this the one that you're talking about, Olivia?
She said something about not. It's number 12.
Oh, number 12. Oh, that's this one right here?
No, it's like in a slap. It's number 12 one. Oh, well, it says in a slap shot.
What year is it? Number 12, oh, here it is. No, so this is not for you. That's going to be chapter 2. So let's hold off on that. In fact, neither is number 11. Right there. Okay, if y'all have any questions over the weekend about, hey, is this question in chapter 1 or chapter 2, y'all shoot me an email. I'm going to be in and out all day on Saturday, but I will get back to you before Saturday night, okay? Or before I go to bed, which I go to bed pretty early. I go to bed about 8 o'clock, so don't send me an email at 9 in it, but I'll get you on Sunday morning, okay? That answer your question?
Yeah, I worked it out, but I didn't realize.
Well, good for you. Yeah, and you're ready for the exam. Hey, let's do this number 8 while we're here. This is a good unit conversion. Remember, 2017 all the way up to 2021. So it says the volume flow rate tells you how much volume of a fluid passes a point in a given time. That's chapter 6 or 7, or chapter 8, I think. Typical adult heart has an output volume of 5 liters per minute. And I want to know it in cubic feet per minute. So let's do this conversion. 5 liters per, what was it, minute? Let's do minutes to seconds first. So I'm going to do 1 minute. And how many seconds are in a minute?
60.
All right, there's 60 seconds. And then the hard part is converting the liters to cubic feet. So I know that 1 liter is 0.001 cubic meters. Okay, so look, that cancels out the liters and leaves me with cubic meters. So a liter is equivalent to 1,000th of a cubic meter. Then I know that a meter is 3.28 feet. So 1 meter is 3.28 feet. And then what do I have to do there?
You just need a cubic
Wait, why do I need to cube it?
so you can cancel it.
Okay, right. So notice here that this meter and up here I have cubic meters. So in order to make this work, to cancel that out, I have to cube that entire term. I have to cube the 3.28 and I have to cube the 1. But of course 1 cubed is just 1. And then that will cancel out that unit with that unit. I cancel my minutes, and that's going to leave me with cubic feet per second. So that's it's going to be pretty small. Is it E? Is the answer E here?
Yeah.
Yeah. All right, so the E is the answer. 0.003 cubic feet per second. Okay? What's the meter?
Light.
Meter is light, right. So it's the distance that light travels. Let's go look at some of these. Oh, I don't think we've done any sig figs yet, have we? Oh, we did that one. But let's try this one. So what do I do first in this operation for number 5? What do I do first? I do adding. Right. So I'm going to add. I do adding, by the way, because it's on top of that thing. So that implies that there are parentheses around it. So I do the 3.4 plus the 12.25. I'm going to keep the lowest number of sig figs.
No, lowest
Number of decimal places.
Lowest number of decimal places. Remember, adding and subtracting, lowest number of decimal places. Multiplying and dividing, lowest number of sig figs. So I'm going to have 15.65. I'm going to make that 15.7 divided by 4.92. And so the number of sig figs would be 3. Because both of them have 3 sig figs, I'll keep 3 sig figs there. Oh, this looks like a good dimensional analysis. Let's try this one, huh?
Which one?
Number 3. You sound so disappointed.
No, I was like, which one are you looking at?
Oh yeah, number 3. So V is the square root of A times X. Is that correct? Huh. Well, V is meters per second. A is meters per second squared. And then X is meters. Oh, but I'm square rooting that whole thing. Are those two equivalent?
Yeah, it works.
They are equivalent because I have meters squared per second squared, but square root. So that's meters per second on both sides. Can y'all look at number 2 and tell me what the answer is? Is that dimensionally correct? The second, not number 2, the second equation.
We can't see the question.
X is meters. A is meters per second squared.
Yeah.
Okay, so far, right?
Okay,
And what about V and T? Does that give you meters?
Yeah.
Let's
yeah.
write this down. So you think about it in your head, let's write it down just to make sure. So meters is x, meters per second squared times seconds squared.
Cancels.
That cancels. That's good. And then meters per second, seconds, that cancels. Check, check, check. All three are the same, so 2 is correct. All right, number 3 looks a little difficult. I know that these two both have meters. That's just what I did up here. So the real question is, does this also have meters? I get rid of the 3. That doesn't matter. The x and the x, I can cancel that out. And so I'm just left with meters per second squared. And then I have the acceleration is second squared over meters.
Yeah, you just left with meters
I'm just left with meters.
on top. So,
Right. Let me write down what I did there again. That was kind of fast. So, first of all, the x's go away. I have x over x, so that's equal to 1. The 3, I don't worry about. So I have v squared over a. V has units of meters per second, but it's squared, so both terms are squared. And then I have 1 over a. A is meters per second squared. Because it's 1 over, it's second squared over meters. The second squared cancels. The meters cancels with 1 meter in the numerator. So we're good on that. Okay? I'm going to try number 4 on your own. Just get a head start and I'll jump in there. Q, x over a equals q over v squared. What are the units of q? Cross multiply to get the expression for q. Or you can multiply both sides by v squared. Either way is fine. They teach cross multiplication. They don't do that anymore, do they? Were y'all taught to cross multiply?
yeah, I was.
Did y'all go to a funny school? Was it a funny school? Or okay. Y'all
I went to a K through 12 school.
were y'all taught to cross multiply?
I missed fractions. Something still because of mine.
Huh? You missed fractions? Oh man.
They tried to switch it like halfway through the year and gave up.
Really?
But I think the year after was
Okay. All right, so here I want to know q. I'll multiply both sides by v squared. That cancels there. And I get q equals x v squared over a. X is meters. V is meters per second. But it's squared. And then 1 over a is second squared over meters.
B.
Is it B? You're getting ahead of me. So your seconds cancel, your meters cancel, and I'm left with meters squared. Okay? All right. Number 7 is a little bit different, but it's still a triangle problem because all I need to recognize is that I have a triangle that is right here, and it has a side here that's 3 units long and a side here that's 2 units long. Now, so I just get that from my Cartesian coordinate plane, and I want to know what is this distance r. So I just do the square root of 2 squared plus 3 squared. That's what, 4 plus 3?
Square root of 13. It's like 3.
4 plus 9, yeah. Yeah, 3.6 or something. I mean, that's the quiz. Unless y'all have specific questions, we'll stop there. But if y'all have more questions, I'll certainly address them. Any other particular questions?
So just in general for your class, are we going to need to know more about trig than just right triangles?
When we get a little bit farther along, there'll be some special geometry that'll come out. So I don't know if y'all studied that in trig. I don't think you did. But no, we're not going to have, huh?
I didn't have trig. Technically, I tested out of it.
Oh, right. Because if you have a 27 or above, you test out a trig. But you still get credit for it. But anyway, not a whole lot more than the right angle trigonometry that I've shown.
That's better one.
You took pre-algebra in high school, that's trig.
Okay.
Some